Hello, this is Bob Laskowski with IT 6873. My OWASP Top 10 presentation is on authentication and session management. What I've done is broken up the two. I'm going to do authentication first. Authentication defined, when applied to network security, we want to make sure who the entity or data claims they are is factual. Some of the reason that authentication is in the top 10 of the OWASP categories is that hackers are always looking for ways into a network. If they can acquire your method to gain access, they save themselves hours of research. Hackers are lazy. They don't want to reinvent the wheel. If they can go ahead and crack an account and gain access easier, that benefits them. You also have to keep in mind that different accounts, different access levels. If they gain a foothold into, say, just a normal user, they might be able to upgrade their permission somehow to a super user or an admin account. The other advantage of them for using this authentication and breaking in with that is that since the accounts are already in place, this kind of masks their behavior. It's a little more hidden and harder to detect when they're using an actual account that's already authorized within the system. Here's a few points of why this is important. We see the authentication attacks were favored in 4 out of every 5 breaches. We also just recently had the celebrity photo hack where people lost their private pictures and whatnot. Then the other issue is, what if someone just masquerades as someone else? Imagine what they could do with that other person being blamed. So authentication is a big issue, and we need to make sure that we protect ourselves with proper authentication. One of the main issues for authentication, and this actually goes for session management too, is there's no real standards in place. Everything's mostly custom built by the developers and such to fit the scheme of what is going on then and there. These schemes are also quite complex, so they tend to have holes where people wouldn't expect them to be. This is, a good point where hackers will sit there and exploit a system and try and find these flaws. And again, each one is a different scenario. When we're looking at authentication, we have a couple of different methods. Of course, the first and foremost, user IDs, passwords, multi-factor authentication. We have some encryption we could use, one-time passwords, and of course, digital signatures. Let's look a little in depth on some of these authentication methods, such as user IDs. We see here at Southern Poly that we have our first initial and part of our last name. A lot of businesses will also use the first initial, whole last name. Well, this is a big problem because this actually gives a hacker a way to forecast what accounts could be. Prime example is, if you're using a first letter dot last name Smith, they can go ahead and use a brute force attack, trying every letter of the alphabet, seeing if one of the passwords they have gets cracked. Another way could be possibly to mask this user ID is the use of initials and numbers, similar where you would use the first initial, last initial, and then a set of numbers. That's a little bit more obscure than just a R. Smith. In some places, they might even have a totally different alias, where instead of using the RS1234 example, as I have there, they might use a different letter and number scheme entirely that would be representative of the RS1234. This is along the lines of the data obfuscation. This is used in electronic health records to try and mask and cover up the records a little more in depth. Another authentication method, of course, is passwords. We all know of the people that sit there and write their password on a sticky pad and put it underneath their keyboard, or they use something like ABC123. These are all in the hackers' password logs, and they're most commonly used things. They would use to try and attack authentication first. We see here a different kind of method for passwords is the Shiner scheme, which is basically taking a phrase, as you see here, when I was 7, my sister threw my stuffed rabbit in the toilet. It breaks it down into letters and numbers, but still kind of keeps the same concept of that phrase, but doesn't have all the letters filled in. This is a lot more difficult for a hacker to go ahead and crack and requires a lot more effort. Basically what they're doing is they take a phrase, they break it down to one word or smaller supposed nonsensical phrase, and it's much more difficult. On the next slide, I have a bit of PHP code that actually shows a validation method for passwords. Here we see a few different things in there. You see the password being validated, a hash, and also a salt. And I'll explain those a little bit further on. What's actually happening there is whenever we have data entered in the form, of course, we know we want to make sure that it's valid and not corrupted in any way. Here, they're looking to check the password someone enters. Well, this method is good for an example here. It's not a recommended method. Normally, when you have a password that someone's trying to enter, you want to go ahead and email them something. You don't want to give direct access whenever somebody's trying to get a password then and there. That could lead to some big problems. And we see this would be an application for a form to make sure that the password fits in properly with the regular expressions, length, complexity, making sure that it's a defense already against brute force attacks. Another common authentication method is multi-factor authentication. Something you know, a password, something you have, security token, something you are, biometric feature, fingerprint, eye scan, and so on. You can have a combination of two or more of these things, giving a layered defense. And typically this would be a use of a card, pins, VPN, digital certificates, fingerprints, and hard or soft tokens. Another authentication method that we would look to give some protection, PGP, pretty good privacy, uses hashes, compression, symmetric key, public key cryptography, SSL and SHTTP, and S-MIME. Another common authentication method is one-time passwords. These are use of challenger responses for users, but they're only good for that session, then they time out. It can be a hard or soft token, emailed or texted password. However, users can be tricked into giving these up with social engineering, and hackers can use that info to devise a pattern, possibly subjected to a man-in-the-middle attacks as well due to the method of transmission for the one-time password. Another authentication method, digital signatures, helps us to prove that the data sent is from a reliable source, gives us reassurance, and it confirms the message wasn't tampered with in transit. Getting back to that PHP example, we're going to see an example of hashing a password. We'll see extra security applied to it with assault. These are examples of defense in depth. No one method or layer is 100% reliable. So what is a hash? A hash is a method in which we take a password, in this case, and apply a mathematical algorithm. This algorithm takes the fixed length password and turns it into a fixed length binary value. Hashes tend to be used as digital signatures for software to ensure it hasn't been tampered with or corrupted when downloaded. However, in this case, we can use it to protect our passwords for our users that attempt to log into our site. Here we see our random salt generator. A salt is data that is applied to a one-way function and added to the hash of a password. When combined with the password, the hashes help to add a new level of difficulty in defending against dictionary attacks. Here are some actual authentication threats. We have confidence tricks, various phishing methods, such as sending an email saying you won X amount of money or Nigeria and I need your help, trying to get more information. Remote technical tricks, spoof, proxy exploits, sniffing, old exploits to technology. Local technical tricks, software vulnerabilities, Trojan, viruses, hardware attacks, victim mistakes, weak passwords, written down sensitive data, user errors, implementation oversights, replays, trusting bad data, sensitive data remembered in forms, denial of service attacks, lockouts for authorized users, and enrollment errors, new set of credentials created. Here are a few authentication attacks as well. Brute force, we all know what that is, just keep on hammering away at it. Insufficient authentication allows an attacker to access a website, contains sensitive content or functions without having to properly authenticate with the website, and a weak password recovery validation. What are the repercussions from authentication attacks? We could have accounts that can be locked out, or the entire user database can be locked out. Outages can occur if there are accounts that do batch work. There can also be a loss of confidence in the business if such an attack is publicized. What can we do to prevent this? First and foremost, we start at the top. We have proper code development. If we think like a hacker, look for what can go wrong instead of waiting for it. Make sure our users are informed of proper passwords, proper security measures, making sure they don't share out information. Have user access lattices, making sure that only access to what they need access to. And also make sure we focus on security and layers, never assuming one layer is going to do it all. On the session management. When we're looking at session management, it's the practice of overseeing a transfer of data between two or more entities. Session management focuses on an already authenticated user. This authenticated user has their information bound to an actual session token ID. Threats to session management. We've already been properly authenticated to a connection, and when we begin to do what it is we do, work, shopping, surfing, the web, or banking, etc., there will be a session identifier for what we are doing, similar to a tracking cookie, if you will. This ID ties you to what you are actually doing. In essence, you're sort of leaving a digital breadcrumb trail. Why is this an issue in the top 10? Well, we have right here, cracking Internet's foundation of trust allows HTTPS session hijacking. What does this mean? Once the session cookie is decrypted, hackers can exploit to gain unauthorized access to the user account the session cookie is designed to authenticate. This process from start to finish takes only a few minutes. And we see a victim of it right here, Yahoo with the Android spam. The weaknesses for session management are the same as authentication. We see that most developers will build their own session management schemes. There's no standards for them. These schemes are complex, and they tend to have flaws because they're not thinking like a hacker. They're thinking only to get the code done and working. And we all know that hackers like to find these things and exploit them. Some common session management methods. We validate session ID values coming from clients. Have hard to guess cookie values. User authentication. SSL encryption. Use of trusted third parties that would actually do our session management. We're simply offsetting the risk of having a bad scheme in place that's been built. We have someone else maintain it. You also make sure set a sufficient session ID length. Same principle as passwords. Complexity and length play a part in making it more difficult for a hacker. Making sure no patterns become evident. Again, we're going right back to if we have the R. Smith example, they can go ahead and hit everything along the alphabet .Smith. It's the same thing as session IDs. We want to make sure that we have no patterns that are apparent. There's also an extra layer of security if we go ahead and associate the ID with an IP address. Here's a session management method in depth, the hard to guess cookie values. We're looking at cookies. We all know that they're a little bit of code that has our authentication to a site that we've logged into. So what we're focusing on is the HTTP headers and allow control over token expiration time and other granular features. This is a common method. That's why they use cookies. The session uses the cookie to maintain the connection, much like when you authenticate. The cookie keeps your credentials active over the session. Making sure cookie values are not easily guessable prevents a hacker from using the values and trying to guess a new one and establish a connection. Another example in depth is SSL encryption. Since cookies are the most common method to establish and maintain the connection, we should also look at a layered protection. Make sure the cookies are sent over a secure line, and also making sure that we prevent a successful man-in-the-middle attack. So this way they can't gain usable data from a cookie. Here are some actual session management threats. Session hijacking attacks, targeted or generic. Session fixation attacks. Brute force. Cross-site scripting attack. Man-in-the-middle attack, man-in-the-browser attack, and prediction attacks. What are the repercussions from a session management attack? Users can be impersonated and damage can be masked. Fraud and or theft can occur dependent upon system access. Worst case, elevation of privileges granted. Best case, compromised account is locked out. What can we do to protect ourselves? We could make sure the use of cookies, use of a secure flag in the header, make them unsniffable, use of restrictions. Don't allow users to determine session IDs. Make sure that they cannot reuse old session info. Each user should get a new identifier to your site. We can make sure the timeout session identifiers, make sure the window is smaller for a window of attack. Allow cleanout logs. These will log out the session, invalidates them on the client and the server. And the use of secure channels for session cookies. In summary, we should always assume that we are not hack-proof. We should make sure we mitigate our risk correctly and prioritize our levels correctly. Take into consideration of what needs to be protected the most and what the damage will be if there's an issue with it. And always make sure to use security in layers and never put all your eggs in one basket. There's a link to the article with the PHP code if you're interested in checking it out further. Thank you.